So if you're in Chemistry 1, we may not have gotten to titrations depending on where we are on the semester, and if you're in Chem 2, you may have done titrations, but you don't quite remember how they work, what they're about. So this video is kind of just meant to give you a big picture view of what a titration is. So when it comes to titrations, what we were doing is we were taking two reactants and reacting them together until we basically hit an equivalence point. So what I mean by equivalence point is we've reacted away one of the other. So we have two pieces of glassware we use when we do a titration. We have a BURRET, and then we have our reaction flask. And within our BURRET, we have our titrant. Now the titrant is basically the whole point of having the BURRET is to deliver a controlled volume. So this is precise, usually just 2 decimal points. The ones we use at Wake Tech, definitely 2 decimal points. And then to our flask, we're adding some known or unknown. So in Chemistry 1, could be potassium hydrobenthylate, KHP. It could be acetic acid. But the point is, we know something about what we're putting in here, and we know something about what we're putting in here. Now in this case, we're going to use concentration in terms of molarity and volume in terms of the amount we deliver to relate this to moles. And we're going to use something about this, either the mass or the volume and the concentration to relate it back to moles. And we're going to connect the moles of what's in here with the moles of what's in here through a reaction. So for a monoprotic acid titration against a strong base, this thing like acetic acid versus sodium hydroxide, it's 1-to-1. When we've hit equivalence, we've reacted away all the sodium, hydroxide with acetic acid or vice versa. So this is one way of doing a titration. You add this to this until you hit equivalence. Now how do you find equivalence? Well, typically you throw in an indicator. So for something like acetic acid, this will be phenolphthalein. Phenolphthalein turns bright pink at the pH range where we expect it to for acetic acid neutralization. Or you can have something that's a self-indicator. Just thing like iron and permanganate. So if we add enough iron, eventually the permanganate solution, which is purple, will turn clear. Or we can have iodate in sulfate, or a starch solution. And the iodate reacts with the starch to turn black, and once we react away all the iodate, the solution turns clear again. So that's one way of doing a titration. Add enough of this until this is completely reacted as indicated by an indicator or by the reaction itself, and connect the moles of what you added to the moles of what's in here through the reaction. The second option, which we do at the Chemistry 2 level, is sticking a pH meter in here, and we measure the pH as a function of volume of this additive. And the idea behind that is that we can get out more information. So if we look at pH versus volume, which we'll talk about in a later video, what we'll see is that we can connect the pH as a function of volume to the Ka, the ionization constant or the dissociation constant or the equilibrium constant of the weak acid, as well as its concentration. So that's your big picture view of a titration. 2 pieces of glassware, your BURRET, your reaction flask. We're using this to react this, and we have to know enough about one of these two to figure out the concentration or amount of the other one.